Hello, AP Calculus students, to another day of Unit 7. So let's get to the bell ringer quickly, and then we'll talk about what today's lesson entails. All right. So another practice AP question, multiple choice. Find the value of the limit as h goes to 0 of 3 times the quantity 2 plus h squared minus 12 divided by h. Now, I'm going to solve this problem two different ways. The first way is the manner in which I suspect most of you would try to solve it. And the second way is, I would say quicker, but it's not going to be the method that it's going to come to you most immediately. So let's try the method in which I think most of you would try to solve it. So we're trying to evaluate a limit. Now, hopefully, whenever you're given a limit problem, the first thing you always try to do is evaluate it at that respective variable value. So in this case, as h goes to 0, so this is method 1. Now, you'll notice if you plug in as h goes to 0, the numerator becomes 3 times 2 squared minus 12, which is 0, and the denominator also goes to 0 as well. So at this point, if your numerator and denominator both approach 0, hopefully you recall that this is a situation in which we can use L'Hopital's rule. So L'Hopital's rule tells us that whenever we have a limit that approaches, in this case, 0 over 0, we can take the derivative of the numerator of the function and the denominator of the function and then evaluate the limit again. So let's take the derivative of the top and bottom of this function. So the limit as h goes to 0 of 3 times this minus 12 over h now becomes the limit as h goes to 0. So we have to use the power rule. So because we have 2 plus h squared. So it becomes 3 times 2 now, 2 plus h to the first power since we subtract 1 from the exponent. Now, we could use the chain rule. And if we use the chain rule, if we multiply by the derivative of the inside is just 1. And then minus the derivative of 12, which is just 0. And then all over the derivative of h, which is just 1. So now if we try to evaluate the limit again, we end up with 3 times 2, 2 plus 0 times 1, minus 0, all over 1. So we end up with 6 times 2. 6 times 2 is 12. 6 times 2 over 1. So 12 or 12 over 1. So our answer is B. So that I would suspect to be the method that most of you would use. But I'm going to go over another method, which is the limit definition of a derivative. If you recall the limit definition of a derivative, excuse me, to find the derivative at a certain x value, we take the limit as h goes to 0 of f of c plus h minus f of c all over h. Okay? So, well, it looks like we have some characteristics that match up with this definition. We have this 2 plus h in the problem, so that is going to correspond to the c plus h, which would mean that our c value is 2, right? If it's 2 plus h, and the definition of c plus h, that means c is equal to 2, which would tell us that 12 is whatever f of c is, so whatever f of 2 is. Okay, so 12 is whatever f of 2 is. Well, let's see. If f of c plus h so if f of c plus h is equal to 3 times the quantity 2 plus h squared, that means our original function, f of x, had to have been 3 times x squared. Because that is the only way, let me use green here, that is the only way f of c plus h could have been equal to this. So you just have to imagine if we work backwards, if we took out the 2 plus h, or if we took out the c plus h, we would just be left with that blank space, in which case it would be an x there, so f of x is equal to 3x squared. So as a result, this is the same thing as asking, given f of x is equal to 3x squared, what is f prime of 2 equal to, because since our c value is 2, well, f prime of x would be equal to 6x, so f prime of 2 would just be equal to 6 times 2, which is 12. Darn it. And we get the same answer that the first method got us. So there you go. So the second method, if you remember the definition, I think is quicker. But if you don't, hey, if you end up just using L'Hopital's rule, absolutely nothing wrong with that. So just remembering the definition that f prime of c is the same thing as the limit as h goes to 0 of f of c plus h minus f of c over h. Or method 1, using L'Hopital's rule, you get the same answer. All right, so let's quickly talk about today's lesson. So today's video is going to be just like these past 2 videos in the sense that there's nothing new. I actually want to provide you guys with another quiz for this unit. Even if you haven't tried the other 2 yet, you still have time to do them. So this quiz will focus mostly on basically the last lesson that we had, which was Unit 7, Day 4, that video. Or if you look at your notes, that would have been Day 114. So if you look at those to study for this quiz, for today's quiz, so it basically just covers the application problems that we looked at. So for example, like Newton's law of cooling, we looked at that. We also looked at radioactivity with Chernobyl, so those types of problems you can study. You can obviously also look at the extra practice as well to make sure you sharpen up your skills before trying the quiz. Once again, the quiz is extra credit. If you would like to try it out, please email me. I will email you the quiz, and then from the moment that you get the quiz, you will have 1 hour to complete it. Once you complete it, take a picture of it, email it to me back, and I will be able to grade it, give you whatever credit you earned. So once again, the quiz is optional, but if you want to do it, please email me, and I'll send it to you, and then you will have 1 hour to complete it. So make sure you free up an hour of time to make sure you have enough time to complete it. Otherwise, I have no updates regarding College Board. Once again, we're still looking at that April 3rd date in terms of more information. So we just all have to be patient until then. Once again, I hope you guys are doing safe. I hope nobody's gotten sick. Hopefully you guys have been practicing that social distancing. Haven't been getting into any groups of people. So I really hope that you guys are doing okay. I wish you guys a good day. I hope the rest of your day does go well, and I will see you later.